Today we are going to create an end-to-end architecture for Apigee's implementation with a shared VPC, and this is the end goal of our architecture implementation. So we will start from scratch and end up with this architecture for our production and non-production Apigee implementation. So let's get started. So what I have done here is, so when you provision Apigee, what you get is you get an Apigee tenant project, which essentially becomes your Apigee organization, and within that organization you can create Apigee's runtime in different regions, and within those regions you will have different environments where you can have your SDLC lifecycle created. For example, you might have QA or dev in as an environment where your Apigee proxies are going to get deployed, and then you can also replicate the same thing in different regions so that you have high availability implementation. So this is our starting point, and we will see how we can extend it in a scenario where you will have a shared VPC for your project, and how Apigee can participate into that shared VPC implementation which you will have. So as you can see, there is already a Apigee tenant VPC which is coming along with this project which is created, and we are going to extend it and build the whole end-to-end architecture for our implementation where we will have a shared VPC for our own project. Now to get started, let's bring in few boxes which will represent our different projects. So I am going to give it a color of something like this, and I am going to call it as our project, and I am preparing it from the perspective of a customer of Apigee, so I'm going to call it customer project, and it could be customer project A, B and C. So let's create 3, so I'll create it as A, and then let's make a copy of this, and I will very quickly explain why I am having 3 different projects, just to mimic how you will have in real world scenario your implementation. So I have these 3 projects, and these 3 projects will have different responsibilities. What are those responsibilities? So let's say we have created a shared VPC implementation, and in shared VPC implementation you will have a project where you will actually create your VPC that becomes your network host. So this is your network host project, and then these other projects will become your service projects. So this is service project, and this also is your service project. Now what you will have in essentially in this host project, you will have a VPC created, and let's create that VPC, change it to something like this so that we have VPC created here. So let's call it our customer VPC, and move this down, and this is our customer VPC created. I just want to change the color to okay. So now we have this VPC created in our host project. So essentially what is going to happen, this VPC get used by your service project, which if we want to see it as a concept will look something like this, that your VPC is extended and shared by service projects, the VPC is hosted in your network host. So this is our scenario. And why do we have customer project A and customer project B? So now we need a way to connect our users, our API consumers. So let's bring in some API consumer. So our API consumer is outside, and they want to connect to our APIs which are running in Apigee. Now by default, Apigee doesn't expose, or Apigee X doesn't expose your APIs created within Apigee itself. What it gives you an internal load balancer which will be created in front. And so let's get an internal load balancer, and I am going to get the icon for this. Let's get this here, So this will be an ILB, and similarly you will have one for this region also. So this internal load balancer essentially is responsible for exposing your regions. So this is how your Apigee is created. Now you need a way to connect your Apigee to your network, and what you will have is you will have a load balancer created in your own project, which will be something like this, and this is the cloud load balancing or external load balancer, which we call it in Google Cloud. So your consumers are going to connect to this load balancer. Now how does this load balancer get connected to your Apigee's tenanted environment? So you have two options which you can utilize. One is using private service connect, and in my previous video I covered that private service connect implementation in quite a bit of details. If you have not seen, you can see that, and you can utilize that information to connect your cloud load balancing to your Apigee instance using private service connect. So essentially what it means is you will have two service attachments in Apigee itself, and let's bring it here, and if I call this as service attachment, so when Apigee gets provisioned, it also creates two service attachments for that Apigee region itself, and there will be one for this. So you can utilize this service attachment. Essentially you can create two backend PSC private service connect negs for your cloud load balancing, and those negs can consume this service attachment. Or you have option of peering Apigee directly to your VPC network. So in that scenario, what is going to happen is your VPC network or Apigee can get peered to this, and if I go and change it to little bit thicker, and it will be like this, and let's bring it to somewhere here so that it's more visible how it is. So this is where you can do a VPC peering if you want, or if you don't want to do VPC peering, you can use private service connect to expose or connect to Apigee itself. Now in VPC peering mode, what you can do, because you are not using service attachment, so you can ignore this for a moment. I will also show you the complete end-to-end architecture for private service connect implementation, which we discussed anyway in previous video, but at the end I will show you both implementation itself. But in this scenario, let's say we have a VPC peering created. So what you can do is you can, since you cannot directly jump from cloud load balancer to an internal load balancer, what you will have to create, you will have to create a jump box or IP translation table essentially. So this is a MIG, which is a managed instance gateway. So what this will do, it is just doing this transformation whenever the request is received, and this request, it will take this request and create a connection directly to Apigee's load balancer behind. So what this MIG is doing is it is working as a network bridge, and this network bridge essentially is having configuration where this network bridge is associated with the load balancer IP of Apigee itself, and you can get this load balancer IP address of Apigee from your Apigee's instance. So whenever you provision Apigee, you will have something like this, runtime IP addresses. So this is the IP address of internal load balancer for your Apigee's runtime in different region. So in service attachment scenario, you will use the service attachment, but since we are using a MIG as a network bridge, we will use this IP address to connect to this. And let me show you how that MIG is configured. So if I go to my instance template implementation, you will see this is my Apigee proxies Europe West 2. So it is also connected to one region, and within that region I will have the IP address of where I am connecting. So if I go down, so here is the endpoint, so this 10.120.0.2, and if I go to my Apigee's instances and I open Apigee, and within my Apigee, if I go to the instances of two instances, essentially means the runtime, so the two runtimes which I have, so this is the IP address of this. And similarly, if I want to connect to this, I will also have to create a network bridge for which is pointing to this IP address, and then I can use this network bridge in my load balancer. So if I go to the load balancer which I have, which is sitting in front, in my load balancer configuration, what I have done, I have used that network bridge which I have created, the instance group, and it is pointing to Europe West 2, and through that it is pointing to that IP address of Apigee where I want to go. So if I have two, I can add another backend for US region also, and then it will start load balancing between those two. So this is how your configuration will look like in Apigee. So now if I want to replicate the same thing here, so essentially what I have to do is I have to move this up little bit and make it little bit like this, and I will have to have another one which is getting load balanced by load balancer, and load balancer will connect to this one, and this network bridge essentially is going to the ILB here. So this is how your northbound traffic configuration can work. And if you want to dictate which Apigee region your consumer request should go, you can create route rules here, and you will essentially have route rules created here, and these route rules based on the incoming request check the region, and then send that traffic to that particular region using this make. And you can do similar thing in private service connect also. In the private service connect also, you will have two PSC negs created instead of MIGs here working as network bridge, and you can still control this. So again, check out the previous video where I talk extensively about MIG. Now why this VPC region is able to call this ILB is because of this VPC peering. Because we have paired VPC of Apigee's tenant VPC and your customer VPC, your load balancer or MIGs are able to connect and call this internal load balancers. Now this is about northbound traffic. So what about southbound traffic? So let's say I have some applications or some services running in my VPC project, and this is why I have another project just to replicate in real world scenario. Let's say I have created some services like it could be any service. For example, let me bring in this. So if I say I have GCP private targets created and I want to call this from Apigee itself. Now how do I make that possible is I can create a load balancer in front, which is a good practice. So essentially I will have a internal load balancer. Let me just copy this, and this internal load balancer is exposing this, and this load balancer will have some IP addresses created for these services. And because these networks are VPC paired, Apigee will be able to call this load balancer from its southbound traffic from its HTTP target endpoints. So essentially you can potentially do this and bring it here, and if I move this up, and similarly this will also be able to call this load balancer, and let's move this also a little bit up. So these two traffic are coming, and this will be my southbound traffic coming in. And this is also southbound, and these two are northbound traffic. Now, so we did this. Now Apigee is able to make this call, and this could be running in different regions and all, so I'm not worried about that, because as long as you have this within a network which is peered to VPC, Apigee will be able to make call to this. Now because these two are peered, Apigee will be able to call this southbound traffic and will be able to reach. Now there is something which you have to be very careful and take note of, which is the transitive peering notion within Google Cloud, or for that matter any cloud. So let's say you have another project which you have created, and this project has its own network created. So let me just make a copy of this, and I am going to get rid of these things here and reduce this little bit. And if you have a setup like this and like this, now what you have done, you might have done a VPC peering between these networks. So let me do this one and create this and move it a little bit here and move this here. So you might have a VPC peering like this, and you create an internal load balancer, you create a service project, and this could be customer VPC 2, and let's call this customer VPC 1. So what will happen in this scenario, if you are expecting Apigee to call this service through this VPC peer network, and you might think that because I have peered this Apigee tenant VPC and customer VPC 1, and then customer VPC 1 is peered to customer VPC 2, I should be able to make this call of internal load balancer from Apigee itself. But that will not work, because transitive peering is not allowed. Apigee will not be able to see these services from through this VPC peering. What you could do is you can create another load balancer here, and this load balancer, if this load balancer is able to call this load balancer, then Apigee could potentially come to this load balancer and go through to this service. That request translation has to happen. Otherwise, if you are directly using this load balancer's IP address in Apigee, you will get a timeout error because Apigee is not able to make this call. So you have to be very careful with this. Now another thing what you can do is you might have some backend services running here. So let's call this as, you might have some on-premise targets. This could be another service which you want to call from Apigee. So if you create this here, and then you will have an cloud interconnect essentially to give you configuration connection to this service, and your cloud interconnect is connecting here. So you can also have this load balancer going to your service behind. For that you will have to create another component which is essentially a hybrid NEG, another network endpoint group, and this load balancer can potentially call this. Ideally you will have a different load balancer, but just for this sake of this implementation, I'm saying that this load balancer is also going to this hybrid NAG and going to. So one point to mention is that you are going through this load interconnect. You are not essentially doing a proxy. It's not a proxy. It's just a network tunnel created for you, and then you will be able to reach your on-premise targets also through this implementation from Apigee itself. Now this is one implementation, so again this won't work. So let me put a cross here just to drive the point home. You can't call like this, but everything else will work. So this is your non-production implementation. So let's say if I get rid of this whole thing here, and what you will potentially have another copy of the same thing. So if I drag in a box around it and change this horrible color to something else, let's say this one, and we call it our non-production non-prod. For example, your test environment, dev environment, QA environment. You can create all this here, and then you will have another replica of this. If I drag this out here and bring this in front, and then you will have the copy of the same implementation, and essentially that will become your production environment. So it will be something like this. And now why I am doing this, I will explain in just a second. So you will not have dev environments here, you will have maybe prod 1, prod 2, or so that you are deploying your API separately. And similarly, this will be also prod 2 just for high availability region, prod 1. So there's something like this you will have. Again, not bothering with size and all, but still let's make it clear. And then your consumers are connecting to your services. Now why I did this is basically to have a clear-cut segregation of responsibility of environment itself. So you can have different IAM controls, different networking, different user access, or where they are going, or who is accessing what, audit controls and everything. So you have clear implementation segregation of your projects itself. So you will have a replication of production and then a dev environment where you can test things out. So this is how you can provision Apigee for a shared VPC implementation which you might have. And then just to drive home a point that what we discussed in last session was, we were using private service connect to completely not peer GCP or Apigee's implementation, Apigee network to our network. So you are using PSCs for northbound and PSCs for southbound, and for VPC implementation you are using VPC peering, or potentially you can also use private service connect. So again, be mindful of transitive peering, and this is how you can architect your Apigee's implementation. Thank you.